Explore and reason. A diver is going through ocean search and rescue training. The graph shows the relationship between her depth and the time in seconds since starting her dive. So the first thing we do when we analyze a graph is we make sure that we pay attention to the scale of the graph. So if I'm looking at the axes of this graph, this is the x-axis over here, which is time, and the y-axis is the depth. So x and then y. In this case, it would be time versus depth. So time versus depth. And as we look at the time, we see that every 2 boxes represents 1 second. But as we look at the depth, every box represents 1 foot. So that's important when you're looking at the different locations of the diver on the graph to pay attention to what the scale represents. We see that the diver starts up here, and that would be up at the location 0, 2 feet. And as divers do, this diver dives below the surface of the water. So the x-axis actually represents the surface of the water. And they dive down to 8 feet, represented on the graph as -8 feet. And then they swim back up to the surface of the water. So part A says, what details can you determine about the dive from the coordinates of the point 5, -8? So after 5 seconds have passed, the diver is 8 feet below the surface of the water. And that is the lowest point that the diver reaches. In fact, we would call that the minimum point on this graph. Oh, minimum. Let's try to spell right, Mrs. Snyder here. Get rid of that, and we're going to spell it again. Minimum. Okay, so minimum point on the graph. What is the average speed of the diver in the water? How can you tell from the graph? So let's think about this. After 1 second, the diver has moved down 2 feet. And then after another second, so let me zoom in on that so we can be completely accurate. So after 1 second, the diver has come down 2 feet. After another second, the diver has come down another 2 feet. So if you think about that, down, over, down, over, down, over. So as each second goes by, the diver is diving 2 feet. So the speed, if you think about speed, what's something you can relate to for speed? How about when you drive a car? When you drive a car, it's miles per hour is your speed. So it's distance versus time. So what's the distance this diver is traveling? 2 feet per 1 second. Now, let's think about that. On the way down, that's actually a negative slope, right? But speed isn't negative. So in this respect, we wouldn't think of it that way. We would still think that the diver is traveling 2 feet for every 1 second. Because then the diver hits that lowest point and turns and is still traveling at 2 feet per 1 second. The question was, how could you tell from the graph? Well, I was tracing off the slope. Now, you did slope problems in your prerequisite skills. So rise over run. So in this case, it was falling So the diver was actually falling over a period of time. But then when it reached the lowest point, it was actually rising over 1 second. So every 2 feet. Which point on the graph shows the starting location of the diver? So the starting location of the diver is right here, and that's at 0, 2. In other words, the diver started 2 feet above the water before they jumped into the water. And the reason that that is the starting location, because this is where time equals 0. So the time equals 0 at 2 feet. What does the V shape of the graph tell you about the dive? What information does it not tell you about the dive? So again, there's no right or wrong answer to this question. For me, the V shape tells me that the diver dove in the water and they were descending. So descending to lowest point, or decreasing to lowest point, and then ascending. Because that's what happens usually when you dive. Think about if you dive into a pool. You dive to the bottom of the pool and you come back up to the surface. What information does it not tell you about the dive? Well, it doesn't tell you what happens after 9 seconds, right? Okay, E. What do the points where the graph intersects the x-axis tell you about the dive? So let's talk about that. First of all, let me go back up to C. Let me highlight something in C. We call that the y-intercept. And for E, the point where the graph intersects the x-axis are going to be the x-intercepts. And those x-intercepts are located at 1, 0, and 9, 0. So let's go ahead and write that down. 1, 0, and 9, 0. What's the significance of those 2 points? Well, the significance is, and you can just see visually from the graph, that is the place where the diver actually breaks the surface of the water. So at 1 second, the diver has now entered the water. And it looks to me at 9 seconds, the diver is back up to the surface of the water, and we don't actually know what happens after that point because it looks like the graph stops. So both of those points represent the time at which the diver is at the surface of the water. And what we did there was an example of ways to analyze a graph. So we talked about the scale of the graph. We talked about what each of those x and y axes represents. We talked about x and y intercepts, and we talked about the fact that in this graph, we have a section of the graph that is decreasing or descending, and we have a section of the graph that is increasing or ascending. And these are all vocabulary words that we're going to use in this topic. Okay, the next thing that we're going to talk about is number lines and interval notation. Now, interval notation is completely new to you. Well, it should be. And so I'm going to go over some aspects of interval notation. So interval notation is a way to express a range of values on a number line or in a coordinate plane. So in the first when you're first working with interval notation, it is helpful to write what you're seeing on a number line using inequality notation. So if I look at that first number line, I see that there's an open circle at 4, and I see that the graph is highlighted to the right of 4 with an arrow at the end. If I were to translate that into inequality notation, that would be x greater than 4. And notice there's an open circle there. And with the open circle, that indicates that we don't include the value of 4. Now, on a number line, the ends of the number line have arrows. And that's because they actually represent more than just the values that you see written on the number line. They represent all the numbers on a line. And as you learned in geometry, lines are infinite in both directions. So if you were to keep on listing numbers to the left of -5, -6, -7, -8, -9, -10, and so on, you would get all the way down to -infinity. So we would see the end to the left on the number line is -infinity. To the right on the number line is +infinity. And it is helpful. First of all, they look like sideways eights, -infinity, +infinity. It's helpful to actually label those symbols on the number line when you are transferring the information from inequality to interval notation. Interval notation uses parentheses and brackets. So if you look down here, what is an interval? All the numbers between two given numbers or between a given number and infinity. So all the numbers between two given numbers or between a certain number and infinity. When we work with interval notation, we use brackets or we use parentheses. A bracket indicates that you are including the value in the interval. A parentheses indicates that you don't include a value in the interval. -infinity and +infinity use parentheses or round bracket. Because as it states here, when we don't include the end value, we use the round bracket. And we would never include infinity or -infinity because we can't reach them. They are infinite by nature of the word infinity. So let's go back up here and take a look at this x greater than 4. And let's rewrite that to interval notation. So the graph starts at 4. The graph moves in the direction of +infinity. Now, it's very important when you work with interval notation and you interpret number line graphs or coordinate plane graphs that you are always reading left to right. So you start at the leftmost part of a graph, and in this case, we're starting to the left, and we're looking along the number line, and we see that the first value indicated by the shading is the number 4. And so you see that 4 to infinity is going to be interpreted as 4 with a round bracket and infinity. In the second graph, we see highlighted the values that are to the left of 3. So again, I will begin by labeling the leftmost part of the number line -infinity and the rightmost part of the number line positive. So keep that visual with you, that to the left is -infinity, to the right is +infinity. And we see the highlighted values are everything to the left of 3, which if you were to write that using inequality notation, that would be x less than, and we would include less than or equal to 3. X less than or equal to 3. Now, what does that look like when we write it using interval notation? Well, when we write interval notation, it is from the smallest value to the largest value. So I want to go back to the previous one and note that 4 is smaller than infinity. Of course, everything's smaller than infinity. So smallest, largest. The interval must be represented that way, with the smallest number on the left, the largest number on the right. So here, the smallest number is negative infinity. And we always use a round bracket or a parentheses around negative infinity. And so the graph represented in that teal is negative infinity up to 3. We include 3, so a square bracket when we want to include the end value. And so now we have inequality notation and we have interval notation. All right, so let's just recap. In interval notation, we just write the beginning and ending numbers of the interval. So beginning and ending numbers of the interval. We use the square brackets when we want to include the end value. On a number line, that's going to appear as a closed circle. On a coordinate plane, same thing. Or it may appear as arrows, might appear as points. And so we'll take a look at that when we get to coordinate plane with interval notation. And the example here, this 0, 20 with the bracket around it, that interval would mean that you include both the 0 and the 20. If you have the rounded bracket or the parentheses, that would mean you would not include it. And so here, write your inequalities from the number line graph using interval notation. So I already did that up above. And here we now have a nice graph which summarizes all the ways you could express intervals of numbers using inequality notation, interval notation, and then something new called set notation. And set notation is really inequality notation with this fancy brackets on either side and the variable x. And so we, like this one, we would read x such that. So that up and down bar there, it's interpreted as, the symbol is interpreted as such that. So we would read it x such that 3 less than or equal to x less than or equal to 4. In words, all real numbers that are greater than or equal to 3 and less than or equal to 4. Interval notation, square brackets, because you are including the 3 and the 4. If you wanted to look at that visually on a number line, like what does this look like on a number line? And that is everything between 3 and 4, including 3 and 4. And so now you can see what that interval notation looks like in its number line form. And we have lots of different ways we can express our interval notation depending on whether we use a square bracket or a rounded bracket, and also depending on whether we're using infinity or negative infinity. And we have to remember that we never use a square bracket around negative infinity or positive infinity. And the reason why is, go back up here, a square bracket when we want to include the end value. A rounded bracket or parentheses when we don't. We can't include infinity and negative infinity because by nature of infinity, it means we never reach it, which means we can't include it. Okay, let's graph the interval notation below. So between 3 and 4, so we're going to have a 3 and a 4 on our number line. That rounded bracket by 3 or that parentheses means we don't include it. The square bracket by 4 means we do include it. So we would close that dot in, and then it is everything between 3 and 4. If we were to write that using interval notation, or inequality notation, I believe that is this one right here. And that summarizes interval notation. Now, when we get down here and we start graphing in the coordinate plane, I'm going to talk to you about interval notation using the concepts of domain and range. So we're going to graph a function. Now you graph some linear functions. So now let's talk about graphing something that is non-linear, which means it is curved. So again, I'm going to choose a couple of negative values, 0, a couple of positive values. And we'll see if that's enough to get a visual of what the graph is. All right. So, and if not, we'll plot a few more points. So if I plug in and I do f of -2, that's going to be -2 squared minus 3. Your calculator will help you, or you can just do mental math. So that's 4 minus 3, which is 1. If I do f of -1, that's going to be -1 squared minus 3. 1 minus 3 is -2. If I plug in 0, I get -3. If I plug in 1, I get -2. And if I plug in 2, I get 1. You see a pattern here. -2, 1, I'm going to plot that. -1, -2, 0, -3, 1, -2, 2, 1. Oh, whoops, I did that one wrong. 2, 1. All right. It looks to me like when you're looking at those points that they create a curve. And that curve is actually called a parabola. Something you might have learned back in Algebra 1. Does the graph represent a function? Yes. And the reason that it represents a function is because every input, and I made up those inputs, -2, -1, 0, 1, 2, matches to one output. So now I'm using these words input and output. My x's would be referred to as my input, my y's referred to as my output. You put the number in, you calculate the rule of the function, and a number comes out. We also have another name for inputs and outputs, and that is domain and range. So the word range got cut off right there. So the x values are your domain and the y values are your range. So domain and range. Different functions will have different domains and ranges. So the set of all possible inputs is referred to as domain. So the set of all possible inputs is your domain of your function. The range is the set of all possible outputs. So let's think about the domain. What sort of values can we use as inputs in this function equation? So I use negatives, I use 0, I use positives. So there are not any restrictions on the inputs that I could use for that x in that equation. I could plug in any negative number, any positive number, and I've already plugged in 0. So we would say that that is all the numbers can be used as inputs. And so the domain is written negative infinity to positive infinity. And that is because there are no restrictions on the domain. You can plug in any value that you want to for x. Another way to write that would be to actually use the words all real numbers. You could do that. But preferably we're going to write our domains as interval notation. Now, as I did on the number line, I will sometimes write negative infinity and positive infinity on the x-axis, and negative infinity and positive infinity on the y-axis. And then remember that my inputs are my x's, are my domains. So I'm going to circle that in purple. Input, x, domain. Your domain for this function is any x value that falls between the smallest number and the biggest number. Your range is your outputs. So let's look at the range. The range is the set of all outputs. So I like to think of range as lowest y to highest y. And so you have to look vertically for the range. You have to look vertically. Your eyes need to track from the lowest part of the graph to the highest part of the graph. Now, when I say the lowest part of the graph, I'm actually going to highlight the graph so that we're looking at the same thing. So I'm going to highlight it in yellow, okay? So let's take a look at the function. Okay, so I've highlighted it in yellow. The lowest point of that yellow function is right here. This is the lowest point. It's actually called the minimum. It's called the minimum point. And that point is right here in our table, 0, -3. Now, your range is the lowest y to the highest y. So the lowest y is -3. The highest y, so think your eyes track from the lowest, that's -3. So from right here where I'm, right here, up. So lowest to highest, so your eyes are tracking up. So that's infinity, because those arrows on your graph indicate that the graph keeps on going. That parabola, that U-shaped curve, keeps on going. So from the lowest, -3, to the highest. Now we have to decide, do we use brackets or do we use square bracket or round bracket? So brackets or parentheses. So -3 is an actual point on that curve. And so I would include that. And then we know we put a rounded around infinity because we never put a bracket around infinity. And that is an example of graphing a function and then describing what the domain and range are of the function. Okay, so the next one says you try it, and I will do that with you. So we will do 2 more, and then we will stop. So again, I'm going to put down some x values. So I'm going to put down -3, -2, -1, 0, 1, 2, 3. The more points you graph, the more accurate your picture will look like. So I'm going to plug in -3. So that's going to be y equals absolute value -3 minus 4. So -3 minus 4 is -7. Absolute value +7. Plug in -2. -2 minus 4 is -6. Absolute value +6. -1 minus 4 is -5. Absolute value +5. 0 minus 4, -4, absolute value 4. Notice all of the values coming out for y are positives. So we're starting to think about the range. What kind of outputs do we have? So far, they're all positive. 1 minus 4 is -3, absolute value +3. 2 minus 4 is -2. 2 minus 4 is -2, absolute value +2, and then -1, 1. Okay, now we have some points to graph, and then we're going to see what this looks like. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. -2, 1, 2, 3, 4, 5, 6. -1, 1, 2. Whoops, I did that wrong, people. Okay. 1. I'm going to just zoom in because I don't think I'm seeing clearly. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, if I stop right now, it looks like it's a line, but it's not actually a line because of that absolute value. So I think I need more points in order to get a bigger picture of what this graph actually looks like. So I'm going to keep on going. I'm going to plug in 4, and I'm going to get 0. Then I'm going to plug in 5, and I'm going to get 1. Then I'm going to plug in 6, and I'm going to get 2. And hopefully you're going to start to see the symmetric nature of this graph. This is actually the absolute value graph. And the absolute value graph graphs to be a V. If we were to do one more, 7 would put us at 3. All right, so let's graph this. We're going to go this way. When you graph using your stylus, if you graph and then you stop, it straightens out the line. It's pretty nice. All right, now we have a picture of our absolute value graph. This is an absolute value function. The question is, what are the domain and range? All right, so look at all the different numbers that I used as input. That's my domain. And so when your domain is not restricted, it is negative infinity to positive infinity, which means I can use any value I want as an input into the equation. My range, as I described to you before, is my lowest y to my highest y. And again, sometimes it's helpful to put your infinity values on the graph. And remember, when you're doing domain, you're looking left to right for domain because those are your x's. These are your x's. Your range is your y's. So the range is the lowest y to the highest y. So if you just scanned your y values, the lowest y value, so we go 7, 6, 5, 4, 3, 2, 1, 0, and then it starts going back up. The lowest y value is 0. So this point right here is actually the lowest point on the graph. We call that the minimum. It's also the x-intercept. So you're going to find that sometimes your points, which we call critical points or key features of the function, have they have two different representations on the graph. So that minimum point is also the x-intercept. So your range is the lowest y. We got to focus on the y's. Lowest y to the highest y. Bracket, because look, we include that point. And round bracket, because we never include infinity. Okay. Last one. And it's another nonlinear equation. And so again, we're just going to pull some x values, plot some points, and see if we can get a picture of what our graph looks like. So I'm going to do -2, -1, 0, 1, 2. And again, like we did before, if that's not enough to get a picture of the graph, then we have to plot more points. So y equals -2 quantity 2 squared plus 6 times 2. All right, so that's going to be 4, because you're going to square the 2 first. -8 plus 12 is 4. Then we're going to plug in -1, and then that's going to be -2 times -1 squared plus 6 times -1. So that's going to be -8. Then I'm going to plug in 0, and I'm going to get 0. Then I'm going to plug in 1, and I'm going to get 4. And then I'm going to plug in 2, and I'm going to get... oh, this was a -2, guys. I did that one wrong. That's a -12. Okay. Oops, I got to go back and fix that one. So if I plug in a -2 here, that's going to be -8, and -12 is -20. And what was -1? -8. Right? So -2. 0, 0, 1, 6, and 2 is 12. Okay, so 2 was 4. No, that doesn't make any sense. Okay, well, let's check it out. Let's see what it looks like. And if we can't figure it out, we are going to have to plot more points, okay? So what we're going to do is we're going to, and then that one that was the -2, what happens if you go to plot equations and the values are not on the grid? You have to plot other points then. Okay, so -2, -20 is just off the chart. So let's stick with -180014. Maybe try 3. If we plug in 3, we're going to get 0. That's another good point. All right, so the first one I wouldn't plot just because it's off our chart. -1, -8. 0, 0. 1, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. 1, 2, 3, 0. All right, now that doesn't really look like anything familiar, all right? It's actually a curve. And once we learn these parent functions, we are going to begin to recognize how we know what the shape of the graph is based on just looking at the equation. So I saw that x squared, which told me that it was the graph of a parabola. It actually dips above there. Don't worry about learning that right now. But we will need that in order to find the range. So we will need to know what that highest point is right there. Okay, so the domain is going to be pretty easy. You see me putting in all those values, no restrictions, so -infinity to +infinity. For the range, we have to know that highest value there. So how do we find that point? It looks like it's right in between 1 and 2. So why don't we test 1.5 as an input in our table? So I'm actually going to go to my calculator for this. I'm not going to try to square a decimal. So -2 times 1.5 squared plus 6 times 1.5. And you get 4.5. So it looks to me like 1.5, 1, 2, 3, 4.5 is exactly that maximum value. And so the highest y value, so that's the point 1.5, 4.5. The highest y value there is 4.5. So we're down here at -infinity. And so, whoops, what did I just do? -infinity down here. So think about it. -infinity, lowest y, up to the highest y. So -infinity up to 4.5. We never bracket infinity, and that is an actual point on the graph. And so